another video. Today we're going to write the implementation for an abstraction that we have in front of us. What we have is a class. We know the private data members, we know the public data members, and what we're going to do is we're going to write the implementation of all of these methods outside of the class. If you have seen some of my previous videos, you would realize that oftentimes if all of these functions are pretty basic, which means one or two lines of code, what you want to do is you would just rather just define all of these functions in line. But sometimes those implementations are bigger and you don't really want to mess up with the structure of the class just like this. So what you do is you create a separate file, call an implementation file, include your header file here, which is rectangle.h, and go ahead and define all your functions here. So what we have is a very simple rectangle class. I'm just trying to explain to you how you can do this in a outside of class fashion. The goal here is to be able to declare an object of type rectangle and have a call a function with reference to that object and see that function work. So you can see in my main function I have my header file included, and in my implementation file I have my header file included. So this file, which is the third file in the solution explorer here, you can see this is I have included my header file. So this is where I'm going to start writing. First, let me look at what my class looks like. My class is two data members, private data members, and my class has 5 functions. 2 of these are constructors and 3 are regular functions. One of those 3 functions is a constant function. The constant function essentially means that you cannot change, this function cannot change the value of a data member. So even if you try to do that, it won't allow you to do that. These are regular functions. These can either change, manipulate the values of private data members. Okay, so first off, I'm going to write the 2 constructors. Important thing here is that because this class right here, this definition, this CPP file, is outside of the scope of rectangle.h, so we need to use something called a scope resolution in order to resolve the scope before defining this function. So a constructor is a function that has the same name as the class and has no return types. So as you can see, constructors have no return types. Constructors are also automatically called. So you cannot call a constructor manually. It's automatically called when an object is created. So when this object is created like this, a constructor is automatically called. Depending on whether you provide values at the time of object when you create an object, whether you provide values or not, one of the 2 constructors will be called. You can have many more constructors. They are all distinguished based on the number of input parameters that they have. A constructor that has no parameters at all is a default constructor, or it's also called a no argument constructor. All of the constructors are then called respectively based on, so these are overloaded functions essentially. Excuse me. Okay, so a very simple constructor. I am going to assign a value to width, and I'm going to assign a value to length, and that is very simple. This constructor is called when the user does not provide a value for this constructor. So in this particular situation, this constructor is called, it's a no argument constructor. Next up, I'm going to write the 2 argument constructor, integer width, integer length. Again, simply assigning these values. Width equals to w, length equals to l, and that's my 2 argument constructor. Now let's go back to our header file and see what are our classes, what other functions do I have. So I have a set values function, so let's go ahead and write the set values function. The benefit of having a header file which you can then implement is that number one, you can obviously use it, reuse this code as many times as you want, but also the implementation will vary from developer to developer, and that is fine too, as long as the implementation does what it's supposed to do, and the inputs and outputs are the same. It doesn't really matter who is implementing and what is being implemented, or how it's being implemented. I'm sorry. So let's go ahead and write the set values function now. Again, so the type is void. Now because this is no longer constructor, I have to mention the return type. So scope resolution and then set values. You have an integer width, an integer length. Again, width equals to W, length equals to L, and that's it. Now you may be wondering why I'm writing two definitions which are practically the same. The reason is that rectangle, this is a constructor, this is only called once, so you only have one opportunity for this function to execute, and that is when a new object is created and the user passes in two values. So this essentially is a, let me write a cout here and say object created. And I'm going to copy this from here and I'm going to paste this right here, object created. This function may be called any time during the execution of the program, so you may want to change the values of width and length during the execution of the program. You cannot do that using a constructor because it can be called. You will need a separate function for that, and that's why we have the set values function. Next up, calculate the area. It has a double return type, so double return type. Again, scope resolution, area, simply return width times the length. That's it. Then we have another function which is a constant function. It prints the object. Constant essentially means that it cannot change the value of the data members. So let's write that constant function. It doesn't return anything. I believe it's a void function, is it? Yeah, it's a void function. Again, scope resolution, print object, constant, cout, width is width. Next line, cout, height is I keep saying it height, it's length. So at any time, if you want to know what the values of your private data members are, you can just call the print object function. Okay, so a recap. We have written all of our functions, 5 functions here. We have all the definitions. The most important thing is this, scope resolution. Okay, scope resolution resolves the scope and tells the compiler that this function which is being defined here is actually a function defined in this class. So that's why scope resolution is extremely important. So let's now go ahead and try to run this and see if this runs. It does, and it should print the area of the rectangle. Object created, area of the rectangle is 4. Now the other way of creating this object is if I provide the values myself. So 4, 5, 4 is width, 5 is length. This constructor is called, and we should be able to see if this works. Sure, 4 5s are 20, so you have the area, and this is the main file. So we started with a header file. Our goal was to be able to use a particular function with respect to the object, by defining, implementing the class outside of the class, and that's exactly what we have done. It's a very simple example. Concept-wise, this is all that you essentially need to know in order to implement classes outside of the class. If you have any questions, please comment in the comment section below. I'll be glad to answer. And I hope you learned something today. If you did, please hit the like button and subscribe to the channel. Thank you very much. Bye.